Good morning, everyone. I'm Ndjido Kane, Director of the Regional Center of Excellence on Dryland Crops of the Senegalese Institute for Agricultural Research, ISRA, and I'm going to present to you SIWA, Crop Innovation in West Africa. SIWA aims to modernize our breeding pipeline to accelerate genetic gain and crop development that meet demand and contribute to development, which is aligned with Feed the Future and ILC vision, aiming at the development of improved variety for key product profile that underpin economic growth, resilience, and nutrient developmental goals. Together, we trust that NAS, like ISRA, could drive innovative agriculture investment that breaks the poverty and hunger cycle in West Africa. The rationale behind SIWA revolves around the opportunity to make very significant yield gain in farmers' field, to take advantage of our availability and affordability of tool, technology, and methodologies, and to utilize well-defined product profile to drive the development of new variety that reflect consumer demand and various end-use quality, as well as serving the needs of smallholder farmers and local value chain. ISRA CERAAS has benefit of the West Africa Agricultural Productivity Program. It was a 10-year program like 9 other Western Africa NAFs to interest specific targeted crops to lead and to evolve from a national center of specialization to a regional center of excellence following ECOWAS criteria. The aim was to innovate, disseminate, and ease the adoption of technologies, as here represented by the arrows. You can see that all the technology sharing between countries. This program also had contributed to address youth employment, women inclusion, and resilience to climate change, to strengthen human and institutional capacity in West Africa, and to pave the condition for regional collaboration. The Innovation and Crop Improvement in West Africa network, shortened by YABAWO here, regroups breeders from NAS program. Since 2015, they assess annually pooled genetic material according to standardized phenotyping methods and a unique repository breeding management system, BMS, and they gather twice a year to share their results with stakeholders, from seed producer to processor and dealers. By hosting SIWA at ISRA CERAAS in Senegal, the scope of SIWA built on the regional approach hunted by ILC to accelerate crop improvement and dissemination across West Africa towards the stakeholders, farmers, beneficiary. The affiliated countries are Niger and Burkina Faso, and the targeted crops are sorghum, pearl millet, and cowpea. They are mandated crops for ISRA CERAAS from ECOWAS. The three crops are well adapted to the environment and constitute staple food for population. Therefore, the productivity gain will underpin nutritional and food security, resilience, and economic growth, particularly for vulnerable groups. The first objective of SIWA is to update existing breeding product profile, BPPs. Master students, gender experts, breeders, stakeholders, and socioeconomists will weigh to the balance to help understand factors and preference of adoption as well as market accessibility. To deploy updated breeding product profile in pipelines and accelerate new variety development, traits related to productivity, nutrition, and resilience will first be targeted. Some other traits showing higher priorities or needs will also be inserted in the BPPs. Further, tested TTMs will be applied to those for rapid variety development. The second objective is to implement modern TTMs for rapid discovery and validation of traits and diagnostic markers for genetic gain and product concept development. Targeted TTMs are gene and QTL sequencing, forward selection, GWAS, QTL mapping, and we're going to use also the Go High approach. We will test the haploid induction and tissue regeneration in pearl millet and sorghum. Crops and traits. In sorghum, we're going to target photoperiodism, protein digestibility, and green mold. In pearl millet, drought tolerance and higher nutrient content will be targeted. In cowpea, maturity, seed size, and striker resistance will be our trait of interest. The objective 3 is to use genomic selection and whole genome prediction of crop breeding value. They show huge potential to explore and increase the genetic gain per selection in a breeding scene per unit timeline. They are economical and viable alternative to marker-assisted selection and phenotypic assessment for quantitative traits. Key advantage is that decision on selection can be made during the off-season, leading to crop improvement in genetic gain on an annual basis. By designing efficient training population with both genetic and phenotypic data, the genomic estimation breeding value of a testing population that have only genomic data could be predicted by utilizing genome-wide high-throughput DNA markers that are in LG with QTL of interest. Various whole genome prediction models are being developed and optimized in crops. For example, at ISRA partner in Siwa, model was used to predict grain yield for test cross and for hybrid in the performance of polymer grain yield, early and late drought stress tolerance, and across various environments. Area of inquiries like trait discovery and genomic selection also successfully deploy the practical haplotype graph in sorghum. The objective 4 is to routinely use aerial, visual, and underground phenotypic techniques like chevrolomics here show, root trait screening methods for drought tolerance like laser ablation tomography, coupled with deep learning algorithms that we are developing at CERAAS in collaboration with the University of Nottingham and Penn State University. Micronutrient contents, grain quality, and further digestibility of varieties that we are being developed under SIWA will be assessed with near-infrared spectrometry and X-ray fluorescence platform available at CERAAS. ISRA CERAAS is also hosting the integrated breeding platform hub to foster the use of the BMS, currently used by sorghum, millet, and cowpea breeders in different national programs. Electronic data capture and management are critical stepping stones in breeding and crop improvement. An integrated analytic pipeline is allowing breeders to digitalize and track their activities using electronic data capture tablets, and to conduct effective analysis, sharing, interpretation, and use of the data. Data management at each NAS is conducted on an institutional BMS instance stored in the cloud. A regional BMS instance have also been implemented to manage regional trials, testing, and store data collected from common materials evaluated at different locations. Although the digitalization of breeding program in the region is moving ahead well with the support of the IBP, some further support for adoption is necessary to bring all programs to the same level of adoption and to reach the routine use of the BMS. The objective here will be to develop, test, and deploy new functionality and new apps like the BACKGROUNG API for data capture and analysis. SIWA cross-cutting activities will address the question how women and youth participate or decide in and benefit from two main nodes of the crop value chain, production and processing. This will consist of understanding and addressing gaps in the knowledge regarding their participation and decision-making process in seed system and the benefit of improved variety and processing opportunities, helping breeders to integrate gender and resilient nutrition in their BPPs, and last, empowering early career research, female and youth, and breeders and stakeholder farmers. So SIWA will therefore complement and reinforce ISRA CERAAS currently designed Center of Excellence for ECOWAS. In particular, SIWA will enhance the use of TTMs, the implementation of gender-appropriate approach, and address the issue of youth employment and job creation in West Africa. Inclusive and participatory approach will be used to feed information, sex and age consideration, and bridge to ensure that prioritized product concept integrate gender, nutrition, and resilience in breeding pipelines. Community engagement and of early career researchers, mentoring by established scientists will support a self-reliance and addressing cross-cutting theme in application in NAS research and training activities. Here, an example of how we do to identify and to validate quantitative traits using BC NAM population in pearl millet. We assume that progeny is derived from the integration of favorable alleles by recurrent crossing seeds exhibits genetic gains for quantitative traits that are superior to the ancestral lines. We develop BC NAM population by crossing female parents selected for their high rates of adoption, resistance to downhill mildew, medium maturity, and good combiner ability for yield, and male parents that are drought tolerant, striga resistance, extra early maturing, and with good combining ability for high grain quality.
Picture shows a BC NAM population being field phenotype under water weight and non-water weight condition. Here is a capture of the protocol and field book for the screening for striga resistance in pollinate during the rainy season 2020. We score striga vigor using the classification from 1 to 9 based on height and number of branches as here shown. With partners, set of markers are being developed and their evaluation is yet to be achieved.
ISRA will partner with National Agri-Food Processing Institution, ITA, WestAfrica NAS in Rwanda in Niger, and INRA in Burkina Faso. ICUSAT Niger, French institution CERAAS and IRD, Integrated Breeding Platform, and Kansas State University. Great thanks to the US government partners in ILSI, to the Feed the Future program, and to you all for your kind attention.